Hello, everybody, and welcome to episode 57 of the Hot Path Show. I'm Johnny, today joined by Danny at Unity, who is actually at Unity. Welcome in, Danny.
I'm
How's
in
it
the
going?
office. It's going pretty good.
Excellent.
Though I don't currently have my own office, but
So yeah, it is now March 20th, and we still have Christmas lights up in the Unity office. What is going on with that there?
that's just cozy. Yeah, it is a little weird, but
I guess it's just kind of the little vibe lighting there or something.
yeah,
But
I mean, also it's dark outside most of the time, anyways. So it's still it has a bit of a mood.
yeah,
To the
yeah.
place.
So software engineer for Core Unity. That's a newish title for you, right? Or Core
Yes,
Core Engine. Let's say Core Unity.
Yeah, exactly. The name of our team did change, so now it's called Core Engine because we're sort of working more on core engine stuff than we are entities, but we're still working on entities. So
Awesome, yeah.
yeah.
Well, yeah. So welcome in everybody to the Hot Path Show. We're going to be talking about some ECS related things because there's some new kind of ECS news, and so of course we'll get some input from Danny on it here. And then kind of the main thing that Danny is going to be doing is you recently gave a talk at a Unity meetup talking about using external libraries in Unity. So these are, like open source, like C and C++ libraries, just that you're finding on GitHub. And you're like, oh, like that seems kind of cool. Like maybe I could use that in my Unity project. So Danny's going to be showing us exactly how that's done. Is that a pretty decent overview of what the talk is?
Yeah. I mean, it's pretty much it's not exclusive to C++ and C. It can also be Rust or Odin or whatever else like external library you find. It's got to be the talk might not work for Python, but like otherwise, any
so
language.
As long as you're not doing like machine learning stuff, then
if you can expose a C function, this talk will work.
Sweet. Well, yeah, welcome in everybody. Seems like we got starting to get a nice little crowd here. Welcome in. I see a good amount of people in the chat here. So yeah, before we kind of get into some things, recently I was wasting some time over on Instagram.com, and I saw something rather unsettling, and I think that you would be I couldn't think of a better person who I would want to ask about this particular thing. So let me go ahead and pull this up here. Recently saw this in Denmark. If you're 25 and unmarried, you get tied to a chair and pelted with cinnamon.
Yes,
Danny, what is going on with this?
This is very true. You can even buy cinnamon bundles to do this. There's a specific website that will sell you 10 kilos of cinnamon.
That's
the face mask itself and other safety gear. It's yes.
Okay. Did you have to go through? Did you have to go through this event?
No. So it depends on your friend group also how if they're gonna torture you that way.
Okay.
So the part of Denmark that I'm from, it is a lot more common to do it than here in Copenhagen. It's not.
Oh, okay. So it's not something that all the city slickers do. It's more the people out in the out in the sticks. And then this goes on to further say here, reach 30 unmarried, and the prank intensifies with pepper replacing cinnamon. Is that
yes. Yeah, same website. You could buy a lot of pepper instead.
Okay.
I think it's still named something with cinnamon, but yeah, no, it's
all right.
It's like an old tradition because we call it a pebermø, which is like someone who lives by themselves is a pebermø.
Yeah, I think I actually saw multiple posts about this. There was like another one, maybe this was in here, but yeah, it was something about spice traders who never settled down, and they would just kind of travel around and never like get married, and so that kind of like tradition relates to that. So, all right, do you know anyone who has gone through this cinnamon?
Yes, I do have some friends who've gone through this. It's not pleasant, mostly from a cleaning perspective.
Okay, fair enough. But I mean, it seems like it's just kind of like a silly thing overall. It's not like
Yeah.
actual like torture or something.
No. You are allowed to have the face mask on and the safety goggles. So you should probably not wear clothes you actually like wearing.
Fair enough. Fair enough. All right. Well, yeah. So just wanted to kind of kick things off with that over there. Another interesting thing that I wanted to bring up. So are you familiar with this game, Ackerhorn?
I am very familiar with this game.
Okay. Yeah. The reason that you may be very familiar, you specifically, and maybe some people in the audience, might kind of jog their memory on this, but this Bonfire Studios, I think they've been working on this game for like almost a decade, I want to say.
Yeah, I think so too.
Yeah. And this audience may specifically know them is because they have been hiring ECS developers like crazy. You go to their website and they're like asking for people who are like, specifically who have ECS experience. So yeah, this is their game. Yeah, Ackerhorn, I suppose you call that. And I think it was just recently in Steam Next Fest, if I'm not mistaken. And yeah, so I think, yeah, they have like a play test or something going. So yeah, I mean, Danny, what do you know about it as far as what you can say?
I don't think I can say anything.
Good talk.
But like, I can only say we've worked with them.
Yeah. That makes sense. Just being one of the big studios, and because I didn't realize that. I can go ahead and share this tab over here instead. So this guy, Rob Pardo, he basically worked on StarCraft, World of Warcraft, Hearthstone, and so now he's leading the studio, Bonfire Studios. You can see he's got the little Bonfire Studios logo on his shirt there. So at this recent GDC, he gave the keynote called "An Odyssey in Building Games That Last," mostly just kind of talking about his development career. I haven't seen the whole thing, but I think there is some stuff on his new game, Ackerhorn, in here. So just kind of want to give a shout out to, this is kind of another of these like very high level ECS games. I think the other big one that is still kind of in the works it's called Den of Wolves, right?
Yep.
Yeah. And so yeah, I mean, there's definitely some big studios who are implementing ECS, and yeah, this one seems to be like a PvP one. I probably would want to ask you more about, if you know anything about their netcode stack, if they're using netcode for entities, but I'm sure you probably can't say anything on that. So, but yeah, I mean, this will be cool to, I don't know, it doesn't have a specific release date yet, but this is just something to keep an eye on for people who may be interested in ECS games with Unity. Anything else to say on Ackerhorn before we move on?
Nope.
Cool.
Sorry for that.
Yeah, fair enough. So, and then go check out the GDC talk on an Odyssey and building games that last if you want to kind of insight on kind of a long career in the games industry here. So speaking of GDC, Unity recently gave a pre-GDC talk. The way that this was kind of presented to me is, and actually, before we move on, do you know how to pronounce the game?
I think it's like Arkheron.
Arkheron. Yeah.
Arkheron. Yeah.
I think I said Ackerhorn or something.
I don't think you pronounced it correctly the first time. That's for sure.
I don't think I pronounced it correctly anytime.
Yeah.
So yeah.
You just consistently pronounce it wrong, and then
there you go. Yeah. It's just a jumble of letters that very vaguely could be that.
It just sounds cool, I guess.
Right. Yes. So the week before GDC, I'm sure many people have already seen this. Unity put out their product update. The way that what I was saying is this was kind of presented to me as they kind of gave their whole big roadmap talk at Unite last year, and this is just kind of them being more specific about some of their plans, and not necessarily like any major changes per se since the previous roadmap talk. So I think a lot of that stuff in the previous roadmap talk still holds true. Shortly after the Unite keynote, I did put a video doing a pretty in-depth dive into all the ECS stuff. So if you want to have a look at that, it's over on my channel. But yeah, so just kind of some highlights from this here. So this is kind of talking about the roadmap towards the full entities integration. And this is kind of showing, sort of the roadmap ahead. So, we're going to be talking in just a moment about Unity 6.4 version that was just released the other day on Thursday. And so these are kind of going into some of the coming updates. So there's version 6.5. This includes multi-thread allocator and modern logging. Danny, are you able to speak to any of these things at all for multi-thread allocator?
I don't know about those. Those two I don't know.
Okay. So I would assume that multi-thread allocator, I mean, that would be, rather than just being able to allocate on the main thread, you can now do allocations on worker threads. Is that like a... Is it, my guess is as good as yours kind of thing at this point?
Yeah, exactly. I don't know much about this.
Fair enough. Modern logging, I wonder if that's just like, I don't know.
I have no clue.
All right. Well, we'll looking forward to some great things in 6.5, I'm sure. All right, 6.6, jobs profiler. So I guess just kind of getting more, probably just seeing some more love for that. Hierarchy support for entities. This is much needed in my opinion. I mean, there already is the entities hierarchy, but it is not very good in my opinion. I mean, it works, but I am constantly getting frustrated with it. Yes. So yeah, I would assume this means that this is now like entities are actually going to be better viewable in the regular Unity hierarchy.
Correct.
Thank you. So yeah, very much looking forward to that. And then we go to Unity 6.7, entities and systems, or entities, systems, and data on game objects. So this is kind of where the entities integration really starts to become a thing, and integrating entities and game objects. Serialization, modernization. If I remember correctly, they were saying things like they're bringing support to being able to like serialize dictionaries and other things like that. So that'll be very exciting on there. And I'm glad that this is actually like a long-term support version where we'll start to see some of these, entities changes and stuff. And then, so it says, 6.8 and beyond is kind of when we get the full entities integration. So I assume that kind of leaves the door open for, not putting a hard timeline on things as far as, not committing to having the full entities integration available when version 6.8 comes out.
But the idea is very much that 6.7 you can already start, using systems and adding game objects. Adding ECS components to game objects and, querying for those entities that are on every single game object.
Nice. So I guess that would mean maybe you don't need to have like a sub scene set up. Like you can just have like a regular Unity scene, game objects in there. Maybe an authoring script, maybe some other way of adding data components to game objects, and then the systems just iterate on those as if they were entities.
Exactly.
And then I guess as far as rendering, I would assume by default it's not using entities graphics at that point.
Correct. Yeah. I mean, like at that point, it would basically be you can do game objects dot get entity ID, and then you can pass that, or you can then get your entity manager and add component data to the entity that lives on the game object, and then have a system query for that component that you just added.
Yeah, cool. That will be very fun. And then, when they talk about the full entities integration, they say entities are now driving the game object updates, and there's serialization of entity data inside game object scenes and prefabs. So that is very much, it sounds like entities is kind of the the backbone at this point, and then you can still interface with game objects if that's kind of what you're familiar with, or you don't need all the features that entities offers and everything.
Exactly. Like a big difference between 6.7 and later. Okay, 6.7.
Get it over with.
And 6.8 is also, as you said, the serialization part. Like you can add at runtime your ECS components, but you wouldn't be able to actually, just have ECS data on your object that lives in the scene. So it doesn't feel as integrated as it will become.
Right. Yeah. The one cool thing that I think they said is that I believe the 6.8 version, they plan on having an alpha available by the end of the year. Is that?
I think so.
Yeah. So so that would be very nice, and then we can start playing around with that as far as so very much looking forward to that. And
just quickly to answer this question, yes, it is possible to use, because UI Toolkit doesn't actually rely on any sort of objects, game object or entities. It's just a matter of getting hold of the UI document. Once you have that, you can use all of the visual elements and buttons and so on from entities code or from systems or from wherever else you want to use it. I actually find UI Toolkit to be the easier UI system when you want to use entities.
Why do you say that?
Because you only need reference to the UI document, and then you can do everything else inside a system. Whereas if you're using like GUI, that's not a possibility. With GUI, you would have to add game objects and get references to those, and it gets complicated in that sense.
Well, so I still use UGUI or just I mean that's just like the regular Unity Canvas UI, right? Yeah,
exactly.
I still use that just because like I'm faster with setting up the UI. Like I'm very familiar with like how that all works, and like so the creating the game object ECS game object references like isn't that bad for me, but I mean I see what you mean, like just having like that one single, you just reference like the UI document and can do everything from there. I'm just not as fast with setting up and using UI Toolkit as of now. I tried it a little bit and it's still just like, I don't know.
The learning curve is way worse. I don't think it's actually that bad when you know it.
Yeah.
And there's some survivorship bias there, obviously.
Yeah, it looks like Mr. Awesome already using a UI Toolkit in my game with ECS. Very nice. The one thing that I will say about having the 6.8 alpha out by the end of the year, that is quite exciting because I have been hearing rumblings of this entities and game objects integration for a few years now at this point, and they've always like wanted like a target, like we're gonna have like an internal alpha prototype or whatever, like do like a small group of people by the end of the year, and that had never came around. But it sounds like, I mean, this seems like a pretty solid roadmap right here, where everything I feel like kind of makes sense as far as like good stepping stones, and at least from the outside looking in, it seems like that the 6.8 alpha will reasonably be out by the end of the year. I'm not going to ask you to.
I will not put dates on any of those versions.
Yeah.
But I do believe that the versions are, the timelines seem correct.
Cool. Well, I'm happy with that. So some other interesting timelines. We got, of course, CoreCLR, kind of getting to this .NET modernization. Seems like it does also have kind of a similar schedule for milestones as far as, we have some things coming out in 6.5, go all the way going up to 6.8 here. So looks like there's some updates to the editor lifecycle API and getting internal CoreCLR player into 6.5. As far as 6.6 goes, so fast enter play mode, which is currently available in Unity right now, but it sounds like they're going to make that the default. And then they say internal CoreCLR editor. Do you know what they mean by internal? I guess
I would that's a good question, what they mean by internal. It sort of feels like it's not for people to be able to use.
Yeah.
I think it just means that behind some hidden flag, CoreCLR already lives in the editor at that point. So if you know the flag, you might be able to
the version of Unity 6.6 that you guys are using, you guys can kind of experiment around with CoreCLR.
Yeah,
and then I guess CoreCLR,
I think the point is also that it will be on users' machines so that it is tested or being used or something like that.
Well, yeah, so then I guess this makes sense. Yeah, they're saying key internal milestone. So on 6.5 is the internal CoreCLR player, but then in 6.7, the CoreCLR desktop player experimental release. So I would assume this would be when you build a project, you have the option to use like a CoreCLR backend.
I would assume that's the case. Again, I don't know for sure.
So, and then, this, I guess, is, the engine isn't actually running off of a CoreCLR backend. It's just the player. As far as like an experimental release. And then, when we get to 6.8, then the actual editor is running off of a CoreCLR backend. And then, IL to CPP on .NET 10. And then we can finally use modern C# inside of Unity.
I mean, I'm personally very version 6.7 it looks very exciting because it's both entities integration and it's you can try out CoreCLR.
Yeah.
I mean,
what's there to look? And it's LTS, so you don't need to worry about them just like randomly dropping support like all these other weird intermediate versions that they're releasing for whatever reason.
I do think it's interesting that while it's LTS, it is also experimental.
Well, it's an experiment. It's an experimental feature inside of a long-term support.
Yes,
version.
But I don't think that means necessarily you're going to get long-time support if you are using CoreCLR. I don't know. I would at least not necessarily expect that to be the case.
Well, time will tell.
Yeah.
No, and there's a lot of, I've definitely ran into some things. I mean, this kind of maybe even ties in a little bit to what you're going to be talking about during the external library stuff. But, there's been a bunch of times where, I've ran into some, like I was using some like C# function that was generating like a ton of garbage. And then I found like a non-allocating version of it, but it's only in like newer versions of C#. And then so I had to like find some external library to
I mean, the funny thing is sometimes you can still use the new language feature if you just implement the like type is using.
Yeah.
Like for instance, I think we don't support the init keyword. Like you can normally do like init only properties, and I don't think Unity supports it. But I think if you add a type with a specific namespace, you can just use it with Unity. I think there's stuff like that in Unity right now. Yeah. So it's gonna be good actually being able to use .NET with all the features and all the new stuff, and yeah.
If you're able to say, have you had any part of this migration towards CoreCLR?
Not other than when they come at my door and need approval, I say, yep. It's like there's obviously code.
You sound like you're like the good parents always go to, like, can we get ice cream?
Exactly. No, but it's more of a there's obviously entities code they have to change. There's some other game object related code that our team owns. That sort of thing, I do have to actually approve those PRs. So, but other than that, I haven't had any, relation to that team.
Nice. Are you still doing mostly entity stuff?
I do mostly game object and entities stuff. Yeah.
Cool. All right. Well, good luck with that. Yeah. Anything else on CoreCLR?
I don't think so.
Okay. Well, yeah, we hinted at it a little bit earlier, but we have a new Unity version, Unity 6000.4, and it is out as of Thursday. And so, yeah, there's some cool Unity ECS things in here that I wanted to talk about. Let's see, does it actually say anything? Yeah, so entities component systems are now core packages of the Unity engine. So entities, collections, mathematics, and entities graphics are implemented in 6.4 as core packages. These packages ship with the editor, which allows the development team to integrate the ECS, to integrate the entity component system. I don't think that's proper grammar, right?
To integrate the entity component system.
Well, I guess.
I guess it is, but I don't think it is because it's a concept.
Right. Yeah.
Yeah, as a concept it's not, but as a sentence it is, right?
Yeah, because it's not like, it's not like a specific system, right?
Exactly. It's not a specific system, which, yeah.
Like you would say to integrate ECS, like to integrate.
Exactly.
Yeah.
Whereas
I would say like Unity's entity component system.
It's a specific kind of system. It's the entity component system.
Right.
That's what it sounds like.
Yeah. I mean, I usually say Unity's entity component system because like it's your like specific implementation of an entity component system.
Right. Yeah.
Anyways, which allows you to get ECS into the engine more quickly. The setup supports ECS for Unity Initiative and ships the features faster and more incrementally. So yeah, now everyone who downloads Unity 6.4 has ECS in their project. Exciting.
Yes.
Yeah, I mean, as far as like, there's not any like major differences other than that now it's just in the engine. And then, yeah, I suppose the thing about getting it into the engine more quickly is there just like less maybe like approval steps that it needs to go through on your end, or like is that
I mean, it effectively just means that it's in the same repository as Unity is, and so when we land a PR, we can land a PR to both entities and to at the same time, and so they're lockstep,
as opposed to doing like one then the other, basically.
Exactly. Like if you there's some packages that are not core packages, and that means that package might be able to support multiple versions of Unity, whereas a package like the render pipeline, universal render pipeline, that package is always released lockstep with the engine, so that's another core package. And so you always need that specific version of core render pipeline in order to,
right,
use,
Cool. Well, yeah, I mean, that is definitely an exciting step towards, doing a full ECS for all and everything. So, yeah. But yeah, as far as like, workflows and stuff for most of us end users, doesn't really change much other than the fact that we don't need to install a separate package now, which is cool. I mean, unless you want to use like physics or something, and then you can, install the entities physics package. But
Yeah.
and then so yeah, the other big kind of ECS change here is that instance ID has now been officially replaced by entity ID. We've talked about this in depth on a previous episode, and I think I broke it out into a clip on my YouTube channel.
I think so. Yeah.
And yeah, this is basically, previously all Unity objects had this instance ID property, which was just 4 bytes. And then now it's been replaced by entity ID, which is 8 bytes. When you actually go into entity ID, I mean, here, let's just do this live here. So I want to see what is actually in it. So, okay. So it's literally just 8 bytes. You're not like, you don't have like a version and
No.
or an entity ID and version on there, right?
No.
Okay. So you're literally just expanding the data field at this point, right?
Exactly. I mean, we're only technically utilizing the first 32 bits. But and then the last remaining bits will be what becomes maybe an entity, the version. Maybe we will add some additional data in there. We'll see.
Cool. And then yes, as far as if you're using instance ID for some things, they kind of gave you a nice little list here of just things to watch out for that are no longer going to work for entity ID. So like might have some issues if you're casting entity ID to int, or so yeah, instance ID didn't use the first bit. So, you can't, were people storing a state inside the first bit of instance ID?
Yes, they were.
Why?
Because we were never, when we allocated instance IDs back when they were called that, when we are allocating them, we were always bumping by 2. And so that means that you can store state by just doing like a modulo 2 on your instance ID number. Right, you get, if you plus by 1, then you get the different version of that number. Yeah. And so you can have a number that you can always store there.
Interesting.
Yeah.
But like, what would people like use that for, like practically?
They were using it for. I was seeing it in like selection code, because when you do a selection, you put the selection in selection.entity IDs. And so you can store additional user data that way. Yeah. Anyways, it's something stupid that you shouldn't be doing, and that's why it's called out here. Similar to how you shouldn't be using object.getHashcode in order to retrieve the entity ID.
Yeah.
The get hashcode function actually just returns you the index directly.
Right. Yeah.
Yeah, there's a bunch of stuff you shouldn't do. One of the fancy things that I implemented is that we put in, when we go and allocate the, like say you allocate a game object or any Unity engine object for that matter, you automatically get an instance ID. I put a special version number in it. And if you at any point lose that version number between you getting it out of the object and then wanting to use that entity ID, like do entity ID to object, I then verify that, hey, you tried to call entity ID to object, but you fucked up the version number. That way I can catch anyone from, having downcasted and then upcasted the entity ID.
Interesting. A lot of fun things that you have to consider, I'm sure. But
yeah.
How is you gotta do the thing from The Office. Have you ever seen that episode where they install those lights in there? Have you? I mean, I know this kind of been in alpha for a little while and out in the wild for only since yesterday really at this point. But have you heard any major issues from has there been people crazy complaining about things or?
Not yet, not yet. So everything is fine.
Sounds good. Let's hope it stays that way.
Yeah. Also, there's to Mr. Awesome the Bruce question of do we then have a dependency on entities and game objects? The answer is no. We'll take a lazy dependency. So only if you have the entities package installed will you get chunks on game objects. So that's the approach we're taking. Entity ID is always in the engine, but instance ID was also in the engine, and it's not a cost the type. So some issue.
Wait, so but entities is installed in the project by default.
No, I don't think it is. It's just the package is present. It comes the package comes with Unity. So you already have it installed locally, but it's not. It's similar to how you also have modules, and those modules you don't necessarily have in your project.
Right. Okay. Yeah. I haven't actually downloaded 6.4 yet, but okay. Yeah. Okay. That makes sense. So it's you still have to download them and stuff, but yeah. And their version number is now like basically tied to like it's now entities 6.4.
Exactly.
Even though it probably should be entities 6000.4, but
yeah, nah. It's the version divided by 1,000. So it's fine. Or not even.
It's like it's like the RPM on like a car. Instead of having like the 1, 2, 3, 4, but it's like times 1000.
Right. Yeah.
So yeah, one other thing that I did want to call out in 6.4 here, talking about some new platform stuff. The web platform, you can now have multi-threaded or enabled multi-threading for burst compiled jobs. So you can now enable multi-threading for web builds using the burst compiler, C# jobs marked with burst compile attribute, compiled into highly optimized native code that runs in parallel on background worker threads. Jobs without this attribute will continue to run on the main thread. So yeah, this is very exciting. I think it doesn't sound like this is full ECS support. I actually, since this is out now, I kind of want to do a video where just like seeing what kinds of things that you can actually do with the web platform now. Because yeah, I think last time I had tried building for the web, there was like some issues loading the entity subscene. So I kind of want to do some things to see like if now does like loading subscenes work. If it doesn't, can we still have entities in there somehow without like a subscene specifically, or kind of just want to like see what the kind of current state of that is. But do you have any thoughts on any of this new web stuff here?
No, it's just, I think it's exciting.
Yeah,
obviously that's also good for entities.
Yeah, totally. Yeah, just being able to have more platforms, and web is still a pretty decent platform, especially for you see a lot of these like games nowadays that like the younger generations play, that are like these like free web games that are like huge, that have like hundreds of thousands of concurrent players and stuff like that. And so so like being able to get more performance out of the web platform, I think is really cool.
No.
Okay, and then just real quick before we get into your talk here, Danny, did just want to call out over on the Unity Asset Store. There's kind of this cool bundle collection going on right now. This is kind of an interesting sale that I haven't seen them do before, where over on the Asset Store, like if you're a Asset Store publisher and you have like a bunch of assets on the Asset Store, you can kind of like package them all up into like one bundle, and you just purchase that one bundle off the Asset Store. So this is just like basically a sale of all these bundles. So you get some pretty good discounts because typically the like bundled packages are you're already getting a discount instead of like just buying them all one at a time. So yeah, I mean, like, if there's any kind of like specific styles for some games that you're going for, this can be a good thing. I need to go through this a little more in depth myself because I do have a game in the works right now, and could be could be in need of some assets. I've already been using a bunch of stuff off the asset store for this one, so very exciting stuff. So yeah, that's what's going on over on the Unity Asset Store, and yeah, I think we can probably hand it over to you.
Oh, is it presentation time?
It is presentation time.
Now the big question
looks
becomes,
like Mr. Awesome has seen my zombie game. I've put some little teasers out there if you go to my like YouTube Shorts page, but recently got the capsule art design for it. I'm pretty happy with it. So
well, should I present?
Yeah, I will let you take it away.
Yeah. So first and foremost, it has been 3 weeks, so I might do this presentation as we go, learn about the presentation as we go, but hopefully I remember most of it. There's a little GitHub link here for a QR code. But yeah, working with external libraries. So it's very common that it's not that common, but sometimes you want to implement an external library either through C or C++ or anything else, Rust for that matter also. There's a bunch of cool libraries out there, often single header libraries, often some kind of parser or something. I've chosen Lua today as the example. So I actually have a project running Lua inside of the editor, and I'm actually going to show that before we continue. So here we have this little Lua example. I set some variables. I call something. I call make cube. I check if student is true, which it is. Then I should print pizza. Let's see what happens. So I printed. Oh yeah, I should press the button. There you go. Something really cool because I called something. I called make cube, so I created a little cube, and I printed pizza because pizza is true. I could then also go and change some piece of code, like I could write false here, and notice how the color highlighting actually works. It's also very nice. That's from a previous piece of work that I did, so that's not the talk today.
I remember that, yeah.
Yeah. And then I can go ahead and run the code again, and we should see it not printing pizza this time. So that's all great. Lua works inside the editor. So that's the example I'll use.
Yeah, so literally the library you're using is the Lua programming language, and then what you're showing is how you can basically type code inside Unity, and then it executes the Lua code and then does things in Unity based off of that.
Exactly. And specifically, one of the reasons I'm using Lua is also kind of hinting at what Mr. Bruce here is saying. Never trust third-party libraries, DLLs. Yeah, I don't trust DLLs, but at least when it comes to like a big project like Lua, I do trust it, and also the source code is available. So you can see here, I actually just cloned source code, and so I can inspect everything I want to inspect, and that's fine.
Yeah, full source available to you to look through and everything. So
yeah, and that's very good. Yeah, so let's see. Enter full screen. Yeah, and it has a little explanation of how you actually go and build Lua, because you can just build it directly from their website. So the first part of understanding how to make a C# program work with a C-style program is to know some of the translating of the primitives. So we need some basic understanding of what's C# versus C++ C types look like, how struct layouting matters, and how strings are different between the two. And also, we ideally want to be able to have C code be able to be called from C# code, and C# code be able to call C++ code. Yeah, so that's what I'm going to go over first. Some of the basic things are like byte is a uint 8, short is a uint 16, int is a blah, 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 blah. A bool is a little complicated because technically speaking, unless you're marshalling it, it can actually be different sizes. There's this here that you can read in order to understand. It's because by default, a bool is technically marshaled as an int, because that is how it was back in C days. But also technically it's not, because in C# it is still gonna be 1 byte. And so it's a little, yeah. If you are ever in doubt, use byte, which is also what burst relies on. Burst can complain if you are using bool instead of byte for some stuff. I think it's across the boundary or something like that. Anyways, so struct layouting. If I have a C++ type that looks like this, the way I would write it in C# is just I would use int pointer, because a pointer translates into int pointer. You could also create fake types for this, but because I don't actually care about the content of the pointer, I can just use int pointer and it's fine, and that becomes my handle. And this just will nicely translate between the two. These types are the same thing. Though sometimes the thing with C# is that C# will actually try to be smart, and due to alignment reasons, it will try to move the fields around. If you want to make sure that you understand the order of the fields inside your C# type, you need to put this attribute called sequential. By putting sequential on your struct, it means that now you know that these two fields are actually ordered that way in the struct. And so when you go and pass the struct from C# into C, it actually is the same type, and they can be understood the same way.
So the memory layout between C# and the C++, whatever you're referencing, basically needs to be identical.
Exactly. It's also, by the way, the best way to make this sort of interrupt code is by doing as little marshalling as possible, because marshalling is actually very expensive. Marshalling is the concept of basically turning your C# data into and copied into some sort of data that C++ can read, or vice versa. When you're marshalling and unmarshalling, it's called. And that's very expensive, and so you should try to minimize it. And so it's better to just have like structs with a promise that, hey, I'm gonna implement the same struct in both languages, and as long as I just pass by pointer and I've made sure to use a native allocation in some way, then I can trust that these two things I can use the same way. Yeah. There's also a difference in working with strings, because in C, C++, most languages have some sort of different version of a string, but in C, a C-style string is generally considered a char pointer, and that char pointer is a bunch of, it's a normal string, but at the very end, it has a null terminator, and that's how that string is defined.
Right. It's just a character array, basically.
Exactly. And it's defined by the pointer to those characters. Whereas here, it's like this very opaque, not at all transparent type called a string. It lives somewhere in managed memory. And so you don't really know a lot of the internal implementation details of what a string actually is, necessarily. The way that you can sort of work between the two is you have to use some of these marshalling calls. Unfortunately, again, I do think you should try to minimize the amount of strings you use in general. You should try to not use strings, but if you have to, this is sort of the way to do it. You here I have I want to set this string from I'm going to pass in my string, and that string lives in C#. And I want to set it as hello world. So I want to write a value into C#. How do I do that? Well, I have a pointer to my const char pointer, and then that's what I set. So this here is gonna save that pointer into my string. And so what we see here is, okay, I have an int pointer. It's just, right now it's 0. I'm gonna use set hello world. I'm gonna call set hello world. So I'm gonna call this function, passing in a reference to this int pointer. So not the int pointer itself, but a reference to the int pointer. And then I'm gonna take this and turn it into a string. Does that make sense?
So are you directly calling this set hello world from C#, like that C++
Yes.
function?
Yeah, and I'm gonna go into how that works, but you should just think of it as this is like calling it. Like this is calling that.
Yeah. And so I guess the reason that you're doing the pointer to a pointer is because you need you're passing it by ref.
Exactly.
In there.
Yeah. I'm passing this string pointer by ref.
Right.
Because I want to change the string pointer. I want to change the value of this.
Yeah, so far so good.
Yeah. And the pointer to string ANC is what's actually going to do the managed allocation. It's going to take that native call and actually turn it into a string that C# understands. And yes, I am indeed giving it a pointer to native memory, which is technically unsafe, but also most runtimes will allow this, because at least for a static string like this, the static string is going to be allocated somewhere in that DLL's binary, and so it's just a pointer to that binary, and so it's fine. And I'm immediately turning it into a C# string, and so it's already, by this point, it's going to be allocated in C#, and it will already have forgotten about the pointer reference. Here we have the reverse thing. I have a string in C#. I'm going to allocate it to a const char pointer, and then I'm going to call it in, I'm just going to invoke some C++ code that has this, and then I need to make sure it's free afterwards.
So kind of like just regular C++ where you're kind of newing and deleting memory almost.
Exactly. I'm allocating something, I'm using the thing, I'm deallocating it again afterwards. Good.
No leaks detected.
Indeed. Okay, now the next part. We now know how we can pass bools, ints, types, etc. And even strings. We also need to have some way of having C++ code call C# code. Because in this example here, we are just like, we're invoking C# code. No, we're invoking C++ code from our C# code, right? And there's a very easy way to do that. What's way more difficult is if you want to go the reverse way around. So in C#, the general way to think of function pointers is this thing called a delegate. And with a delegate, you can just, like, I can save things as a delegate, and then I can just invoke the delegate. And this is the example of that function that has the same signature as my delegate up here, right? It's just a void function that takes a parameter of Lua state. And this function down here matches that signature, and that's why we can store the function in a variable and call that variable. That's a function pointer or delegate. Now, the thing is, we want to somehow turn this into a thing that we can invoke from C++, or any native code for that matter. Now, C# actually implemented this thing called a unmanaged function pointer, which is very nice. In C#9 and above, something we're gonna get that is technically already there, but also not, this specific syntax here is not supported by well, it is supported, but it's a version of it is not supported. There's an attribute you can use in order to effectively use it for our scenario, which you can't use. So in the future version, this is going to be way simpler, but I'm going to show you the trick for not doing that little ampersand. Because the thing is, we can get our function down here where we have implemented some piece of code. We can turn it into a function pointer, which is valid syntax in Unity. The function pointer itself is fine. It's a little ampersand that can be problematic for a reason I'm going to show in a second. And then I'm going to save that, and I'm just going to call it. So this time I'm using, like, this is the type, right? This is the function pointer type. And the way to read it is, it's a function pointer, a delegate pointer, and it points to a function that has a void return, and you pass in a parameter of Lua state, which is exactly what we also see with the additional registration. It's a void function that passes in Lua state. So this becomes a valid function pointer that you can then invoke. Technically speaking, I should have added, code in here, like the parameter itself, but yeah.
You kind of like, defining the method signature almost with that delegate. And then, that line 6 would be where you were calling it, but then you would pass in like a Lua state in that case.
Exactly, yeah. Now, here's what you would then do to actually do the same thing. So here we're just using an ampersand, which is very nice syntax, but we can't use it to turn it into a unmanaged function pointer. Right now, it's actually what's known as a managed function pointer. But I'll come to that in a second. So let's say I instead did the thing I did before, where I am still using my delegate, the delegate I described up here, and I'm then saving that in a variable. I can then ask our marshalling code to please get me the function pointer of that delegate. And then that's what I can cast into this. So this is what we saw before, right? Oh, oops. So this is the same as this, right? You can see that we moved this piece of code. It's the same function pointer. The thing that's different is instead of an ampersand, we need to use this function.
Okay, so you're just calling a function before, and then you can do that same. It's basically a cast of what you're doing.
Exactly. I'm casting our delegate into this.
A specific type of delegate which has that method signature.
Exactly. And then I can still invoke it like I did with just the pure function pointer. Now here comes the magic, because I need to turn this function pointer into an unmanaged function pointer. And the way I do that is I first have to go up to my delegate and say that it's a cdecal. Now that I've done that, it actually becomes an unmanaged cdecal function pointer.
And what is a cdecal exactly?
That is the C declaration calling convention. So that means that, so there's a bunch of different ways when you have a function that you can actually, that code in your machine understands to call another piece of code. And generally speaking, you can sort of think of it as like a contract that, hey, all my parameters, when I call, before I go to another function, before I call it, I'm going to set up these registers with the information that is my parameter data that I then call into that function. And there's some different contracts depending on the calling convention. So cdecal is probably one of the most common ones. There's also something called std call that is an alternative to that. And it's actually what C#, Mono, etc. uses by default on Windows. So before, when we saw that this was a managed function pointer, right, this thing here, it actually, the reason it's called a managed function pointer is because we can't guarantee for sure that this is a std call function pointer, or it's a cdecal function pointer, or any other kind of calling convention. because that is based on whichever device it's on. But by specifying to the delegate that, hey, you should always be a CDECL, we can guarantee that it is always going to be a CDECL. And the reason that that's important is because when we go and invoke the function pointer down here, there, it needs to understand, how am I supposed to call this function pointer? Do I create the parameter stack in this way? Do I create it in another way? What do I need to do in order to even be able to call this function that you provided me as a pointer?
Right. I guess it's almost like an encoding. You could think of it like, there's like different ways that you can store like a text encoding. You can have, UTF-8 or UTF-16.
Exactly.
This is kind of like defining like, basically the standards that it uses to make that function call.
Yeah. And the only thing you're really doing up here is you're telling C# that anytime you have a function, like a delegate anytime you have a delegate and you then try to do the get function pointer for delegate, you're guaranteed to get a CDECL spec function pointer. So you should, if you have this attribute on your delegate, then you should always make sure to specify that it's unmanaged CDECL instead of just thinking it's managed. Because by default, without the attribute, it's managed like this. Right. And technically speaking, this pointer we could now just pass directly to C, and we can start using it, which is very nice. I'm going to show how that looks in a second. But there is a caveat. If you're using IL2CPP, so you're building for Android, PlayStation, whatever else needs IL2CPP, you need to add this to the function you're calling into, this attribute here, where you're basically just saying, hey, this function, I need it to be this kind. If you're called from a function pointer, it should be this kind of function pointer, right? Or this kind of delegate.
So it's like the same thing, but the other side of it. Like the same thing as like the CDECL, but the other side of it, like on the receiving end almost.
Yeah, exactly. You're effectively saying, hey, I'm ready to be called from C. You're saying to this function, I'm okay with being called from C by saying monop invoke of this one up here. Versus the other one, which is saying, hey, whatever this kind of delegate stores is going to be retrieved as a CDECL function pointer. This is just saying, hey, I'm also okay with being called from C, or guaranteeing that it is okay. If you don't add this, you might get subtle bugs, because it's just going to imply whatever calling convention. And so it might be fine on some platforms. And also, the thing is, calling conventions, there's an overlap in some of them. So if you have like no parameters, there's a good chance that I think STD call and CDECL spec just works. Like if you don't have any parameters, but because the convention is only different in the amount of parameters. So you might get subtle bugs if you don't add this.
Those are probably like some of the hard to track down bugs too.
Yes, exactly. Because you're expecting parameters to be a certain way, and they are not. Yeah. But the basic gist is you can pass a function pointer down to C, and then I can call it from C. And if I then actually go into some piece of C code that does that,
Macintosh, look at you.
Yeah. Can I zoom in?
Yes, Thank you.
Here you can see the function pointer. That is the same, exactly the same signature that we just saw a second ago in here. So it is return void, pass in Lua state. Return void, pass in Lua state. it just looks slightly weird, the function syntax in.
And so this is the actual like Lua code that you're calling, right?
Exactly.
Like
this is the actual C code.
The external C code, yeah.
Exactly. And so you can see here, this is the variable. Like if I actually, yeah, that this is the name of the variable, and then I'm just passing in L. So now it's it's going through this first, and then it's calling this, and then it's like we're creating a new version. We're setting up Lua. We are then checking if we set up Lua correctly. Then we are adding the Lua libraries. Then we're registering a print function into Lua. And then we, from this piece of code here, we call back into C#. And then once the C# call finishes, it will continue, down here and then down here into this, close down Lua, and then.
Now, did you change anything in this source, or like this invoke Lua, like this came with the library and it has this like ability?
So this main.c file is just one I wrote. It's very small, as you can see. It's 70 lines of code. So all I did from a C perspective is I followed the little guide that was already present on the official Lua website to build Lua. I then created a C file that referenced it using the includes, and then I just compiled it as a DLL, and that's all I have to do. And I'll get to that in a second. But effectively speaking, I then, by default, every call in C is public. Yeah. And so you can always call this function. Yes. Now, okay. So in Unity, there's like two ways to get hold of, like to be able to call C functions, and it's through DLLs. There's this thing called automatic loading, which is DLL import, which automatically tries to load it. And then there's a manual way of loading it, which I'll go into why that's nice. And it basically comes down to the difference between using an attribute versus having a function pointer that you call. So say I have these two C functions, right? I've written these functions in C. The C# thing I would have to do is I would then, create a little static class. I would add DLL import. It is so cool you can do this, but don't. Just to quote. Yes, I do agree. However, there's cases where you would want to do it. And also, while it is platform specific, it doesn't have to be. And that's also why I show you this thing here. This thing means that it will work for every platform. In any case, going back to DLL import, the nice thing about DLL import is that you don't actually have to specify .dll for Windows and .dlib for C++. Sorry, Mac. Overall, there is like, let me see. There's DLLs, there's dlibs, there's .so, and those are like the main ones for libraries. And when you go and build a library, you just need to specify which platform you're building for. And it depends on the kind of like language you're using. So if you're using C, you just have to find the GCC or Clang or whatever else compiler for that platform. So actually something that's very nice is, let's see, do I have the Unity Hub? Boom, boom, boom. So like what I'm doing in order to build this piece of C code and turn it into a DLL is I have a make file, and that make file is just calling GCC, which is locally installed, and so that is the Mac version. So it knows I'm going to build a library for Mac, and that's the default. Like I can call GCC, and that's the GCC that is built in if you have Xcode installed. But say I wanted to build for Android. Well, probably the easiest way in order to guarantee that it works with that platform is just you go and find a version of Unity, and then ideally you have a version of Unity that has some sort of let's see if I have a version that has Android installed.
Do a little tvOS dev there.
A little bit of tvOS dev. Reveal in Finder. Then I can open it up. Contents. I can find the different. Where is it? There should be. Boom, 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 boom. Because whenever you install a different player, it will have the different players in here.
Right.
So I think maybe tvOS is one of the few that doesn't. But like if I were to install WebGL, for instance, I would get mscripten in here, and then I would just call exactly what I would call GCC with, but with mscripten instead, and it would just do the magic, and it would just work to create their version of a DLL, which is a WebAssembly. Going back to here, now that I've created a valid DLL and I've put it into Unity, I can just find it by name. Yeah. And so it will use the name of the C++ function in order to find it. So if I in my C code exposes that get Unity log, I would also in C# have to find it as get Unity log. I can also use entry point in order to say it instead if I wanted to have a different function name for it. Does that make sense?
Mostly.
Yeah, I can try to show Unity again. That might help a little. So like in here, I just have a folder called lib where I have copy pasted the DLL into.
Yep.
And you can see that it's called Unity interface bridge.bundle. And so by using this name, it has the exact same search string as this without the dot bundle, right?
Yeah, so it's almost like you're like doing like a resources.load. It's just like going to the lib folder, like it just knows where to look basically.
And also, yeah, it knows where to look, but it also just knows where to. It has a search order, but it will.
Yeah, like a hierarchy of like where it looks first or whatever.
Yeah, lib is not a special name.
Oh, okay.
Yeah, it would look in here first. I think I'm pretty sure it will look here, and then it will look in subfolders. For there to be a DLL with the name Unity Interface Bridge, and then once it has found that DLL, it will then look at the DLL and say, "Hey, is there a function called get Unity log?"
And then it just calls that first, basically.
Yeah. But also, as soon as it has found a valid DLL, it then loads it. So DLL import will just load it, and then Unity will actually never forget that you loaded it. So it will just keep being loaded, if that makes sense.
Yeah.
Well, like it, and the thing is, when I say it will keep being loaded, it also means that say you change a piece of C# code, C# then has to reload the code using domain reload and actually change the managed DLLs around and like shut down C# entirely. But that native plugin that you added will still be loaded. So say you were using a static variable inside your C++ code, you can actually keep data around similar to session state in Unity because the DLL is always loaded and it just keeps being loaded.
I feel like I've ran into something like that before.
Anyways, I can just shorten it. I don't need the entry point because I just have the same name anyways. So here's the example of what I mean. There's the plugin lifetime where say I have a number written like this in C++ code. So this is C++ code. I then expose a function to C# called add one and return number, where I just add one to that static number and then return that number. And then I expose it.
Splitting the atom there. Goodness.
Splitting the atom? What do you mean?
You're adding one to your number. I'm like, dude, it's like you're splitting the atom over there. Some serious stuff.
Yeah. So I'm just adding one and returning the number, and that's what this function from C# does. The thing is, because as soon as it loaded, the first time you call this function, it will go ahead and find the DLL and go ahead and load it into Unity. And as soon as it's loaded, it now keeps it. So no matter the amount of domain reloads you do, the next time you then go and invoke this function, it will return the number 2. And then the next time you call it again, it will return the number 3. All the way until you close Unity. And that's the only way to stop it, is to close Unity, and then it gets reset. And this is both good and it's bad. It's good in the sense that now you could actually store persistent state. Now you don't, like for more advanced data, you might normally be forced to use session state. There's the Unity session state API that will keep persistent state around during domain reload if you want to persist state through domain reload. Now you don't have to do that. Now you can just have a native plugin, keep that data living, and that's fine.
Well, isn't also, I think in the migration to CoreCLR, they said that domain reload is like basically going away. So like, will this kind of style, or like you can just kind of do something like this regularly in Unity now or soon?
No, that so it's important to note that there's also an expense to calling into C code. Like you actually should minimize the amount of C calls you do whenever possible. Like the main reason that I'm talking about it today is to actually discuss the implications of doing this, because it's amazing that you can do it, because it means that you can use libraries that you wouldn't be allowed or that you couldn't really use before. Like some C header libraries are small enough that you can just convert them to C#, and you probably should do that then. But other times, you might just want to create a quick tool because maybe you have a specific model layout that you want to import or something like that, and someone already wrote a tool to do that. Like say you wanted to read from a map, like a Google Maps of some sort, the chance is lower that it's going to be written in C# than it is already written as a simple single header library or whatever else in an existing library format. So like I would not suggest actually using external libraries, but at the same time, there's reasons to do it, which is because you have some sort of specific format, and it also tells us how the engine is written, because you have to remember Unity itself is a mixture of C++ code and C# code, right? And to Bruce's point here, every DLL, yes, has their own heap and stack, and that can be a problem, especially because it's costly, which is, again, another reason why you shouldn't do this unless you have a use for the C++ code in the first place. But say that you have a use, there's actually ways to get around it. For instance, with the heap, there's a plugin for there's a API that you can use that is Unity API that allows you to allocate Unity memory instead of allocating DLL memory. And I'll go into that in a second, actually. So you can sort of get around that side effect of it. Yeah. Anyways, back to the schedule program. When I go ahead and load this DLL, I can also specify that it should already load on startup. The difference being that, as I said earlier, the first time you do a call to a function that has a DLL import on it, it will load the DLL. You could also just have it loaded from startup, and so that data is already present. This is also nice if you have, like, I don't know, you want to set a timer, and that timer should then be, start ticking as soon as Unity started up. It shouldn't start ticking as soon as the first time you happen to have called a function that is relevant. So automatic means you reboot Unity whenever you want to make changes. Also means that you have to reboot every time you make changes to the native plugin, right? So when you're working on the DLL, all of a sudden you have to close Unity down. Yeah. So there's another approach we can take, which is to manually load DLLs. And then, because we're manually loading the DLL, we can also control when it's loaded. So, yeah. A core thing that we need to understand first is some of the basic Unity lifetime hooks. I love chat right now.
We appreciate the super chats there, Mr. Austin. By the way, you did send one in before the stream that I want to acknowledge as well. So, Daddy Dots.
Okay. Say we have this very normal looking mono behavior, and there's serialized fields, and we are retrieving the text from it. Then we are invoking our DLL, and then we're doing something. So this is normally how the code would look in the case we're using DLL import. But as soon as we are switching to the manual approach, we should also do this very common thing that we know from working with Dutch code at the very least, but also if you work with C code, we have to have some point at which we say, hey, we're going to load everything, and then a point at which we're going to say we're going to unload it again. And so here we're saying, hey, we're going to load the calls, and then we're saying, hey, unload the calls. Right now, I'm leaving the implementation details for later. Then we can split that to start and destroy, and then we know that our code we can use any Lua for Unity calls until I've unloaded it, so until this object is destroyed, right? And then I might even be able to move it even further. I could have a load manager, and then I know that as soon as my domain starts, so the first time that the C# code has been loaded, it's gonna load our calls, and then as soon as we unload, as soon as we do a domain reload, we're gonna unload the DLL. So this just means that now I can go ahead and make my C++ changes, work on them for a little, and then I can trigger a domain reload, and the plugin will also get reloaded, right? But then you should probably also make sure that you check whether Lua for Unity is available. So you can just have a little call for that. Obviously, this code should always work, so you don't need to check, but you can also put the check on every call if you wanted to design your API that way. Now, the way that load calls works is very simple. If we haven't loaded the library, we load the library at the path of the library. We then make sure that we actually loaded it. If it's still 0, that means something went wrong, and we should log the error for why it went wrong. And then we can just ask, so, oh, whoops. Yeah, and then once we know that it's actually loaded correctly, we can just ask, hey, this DLL that we just loaded, I know that there's a setup plugin function inside of it. Just find that, and then it finds it. And hey, I know that there's a teardown plugin function in there, so I'm just gonna find that. So I'm just finding the function pointers, and then this is now a valid function pointer that I can then just invoke. And then unload calls is the reverse of that. I just ask it to free up that library. Now these things called native loader.free library and native loader.load library and get last error string is actually platform dependent. Again, working with plugins is not necessarily easy, but it's also not that difficult, I want to say. Because here's the thing, it's if I want to implement this load library function, here's how it actually looks on Mac. So I do a DLL import of this specific library, and then it's DLL open with 0x1. And for the Windows scenario, it's load library instead, just passing in the string directly with the path. And that's it. If you go and look at the way it's written in my code specifically, you can also see C# project.
Yeah, Bonta says here, this would have saved a lot of opening and closing.
Where is it? Yeah, native loader. There we go. There you go. So now you can see in the case that I'm calling the Mac version, I'm calling DLSim. Otherwise, I'm calling the get progress address, which is the same thing in, that's the Windows version. And so I would just need to go in and add a version for each platform that I want to ship on. And so if I'm only shipping on, like for instance, with the Lua thing here, I might only be shipping on desktop platforms because I've decided that's what I want to ship on. Then I only know, then I only need 3 of these. And actually in the native load library here, I only need 2 because this dlib is both in Linux and in macOS. It's in Unix. It's a Unix thing. Right. So I've already talked about the project setup, so I don't need to specify that. One thing, if you're building projects with C, I can recommend learning what a Unity build is. I can generally recommend this video. Funnily enough, a Unity build is not related to Unity. What a Unity build is just a, hey, instead of having one file where I include A and then I include B, and then I need to merge my 2 different files together. So instead of, like, say I work with a bigger C library and it has multiple C files, it can be very complicated to create the correct GCC call that actually builds it correctly and does the things that you expect. So let me just do the simple thing. Let me just have one C file, and that's the one I'm calling, and I'm just going to include every other in that singular C file. And so you don't have to think about a big build system, and there's like a bazillion different build systems, and they're all terrible. There's so many bad build systems. I can recommend just having a Unity build file, and that should be it. Yeah. Really good video for learning how to write proper C. There's also the thing about like what functions in C are public by default, and the answer is everything. Every single symbol is public by default. And so that means if I go into my C code here, that means that this function is just exposed by default. It means that invoke example Lua is another function that's exposed. My Lua print is another function. If I were to expose this one, both of these functions are exposed. This function, but also all my static variables is also a symbol. So these two are also exposed. Right. So all symbols are exposed by default. However, you can use, when you have your compiler, you can say F visibility, and then it flips. Then everything is private by default. And then you have to specify underscore decal spec for Windows, and for Mac, you have to do an even more annoying thing called underscore attribute visibility default. So I recommend having this little define, and then you can just put this in front of every function that you want to be public. And that's probably the more better way of doing it, right? And then it comes to, hey, how do I then know what my DLL exposed? On Windows, you can call dump bin exports on your DLL and say, oh, hey, what did my native DLL actually export of symbols that I can play around with? This is also fun if you have like a different DLL, then you can see what they are doing. And on any Mac/Linux machine, you can do nm. And I'm going to show how that looks. So if I call nm, actually I have a make command. So if you look here, I have a make command called view all symbols that is going to call nm-c. Actually, it's this one, -g on my DLL and also my other DLL, because I have two DLLs. Here we go. And so it called nmg-d on my Lua example DLL. And so it exposed all of these. So these are all of the names that I could have used when I did the DLL import or when I did the native loader get function. So all of these I could have found. Also in the Unity interface bridge, I could have found all of these DLLs. Oh, all of these functions or symbols, right? And so also that maps to what we saw earlier. So in this file here, what can we see? There's a get Unity log. There's a get Unity log function. There's a get Unity interfaces. There's a get Unity interfaces. There's a Unity plugin load. And there's a Unity plugin unload. And then there is, well, the G means something different. Let's see what the other make command was. Dual simple make here. Then you can also see these two symbols. S-Unity interfaces, S-Unity interfaces, S-Unity log, S-Unity log. So all this file here produced these symbols, right? And those are the symbols that I could then have loaded from inside of Unity. Yes. Good. Let's continue. Now, if I were to just use printf directly, I wouldn't actually be printing in Unity's own console. I would be printing in Unity's editor log. So the question then becomes, how do I actually interact with Unity itself from my plugin? Like, how can I make my plugin know that Unity exists and call normal Unity functions inside of my plugin? And the answer is that Unity actually provides a lot of different header files that you can then just use. And these header files are just like they're an implementation example, and so they actually do work in like Rust and SIG and all of the other languages. You don't actually need the header file because they work on a very simple principle. And so what you need to do is you open up Unity Hub, you go to Reveal in Finder or Reveal in Explorer on Windows, and then you look at the contents of that folder. So this is my install of Unity. And then there's the plugin API. And so here I can see all the different Unity like API that I can use. And one of them is Unity Memory Manager. And that's how I can use Unity's own heap in order to allocate things that I can use. So I don't actually need to use the heap of that DLL. I can use the heap of Unity by using the Unity Memory Manager.
What's the general process for doing that?
So let's look. Let's just open it up. So if I look in here, there's an allocate function, there's a deallocate function, and there's a reallocate function. And so the allocate function, well, the way it works is you first use the create allocator function, where you specify the name of that area and the name of the allocation that you're doing, right? And then you say, hey, with this allocator that I just made, because this returns a pointer, so I'm passing in that pointer, I want to allocate this many bytes with this alignment from this file and this line. Obviously, you can keep these as like fake values. You don't need a proper value, but you probably should have the allocation point, right? And then you can use deallocate and you can use reallocate as well. So deallocate is the free function, and so you pass in the same allocator that you used to create it along with the pointer. And this just needs to be the place that you deallocated. It doesn't need to be the place, the actual deallocation.
So like from your C# code, you would just call one of these allocation functions, and then with that allocated memory, you can like say pass that into like something in an external library kind of by reference, basically.
Well, yes and no. So what you would do here is, and I have an example of this, obviously. Like say you were using Unity logging. So Unity log here, Unity log. It looks like this. So it exposes a log function. And it uses the squid here. Then in my C++ code, I use this. I just create a function called Unity plugin load, and it will this will be called as soon as the plugin has been loaded. And here I can set up anything I need. So I get what you can see here is there's an Unity interfaces passed in, and then I can use that to retrieve the logging. So I use Unity get interfaces for using this interfaces with this thing here, and this thing here being just known here, like here. So is Unity config, that's this, right? That's what's passed by the function. And so when we load the DLL, the Unity plugin load is called. And so you pass it, Unity passes in this for you, which is passed in here. This name here just maps back to this name here, which maps to these numbers. So I could have also used these numbers directly instead. And now I just use that to do the logging. So anytime I want to log, I use this. I pass in the function pointer I got. And that means I can do everything directly from within my plugin. I don't need to go through Unity first. If that sort of made sense.
Yeah, and there is a related question here. So how fast is the allocator? Is it mostly for allocating a big chunk at the start, or small allocations performing as well?
I mean, my understanding is it's using the same allocator that we have, and so it has the same cost that our allocator has. So I mean, my general recommendation would always be to make a big arena and then just like allocate what you think you would need upfront, so you don't constantly allocate. But that's always the case for when you do malloc. You should malloc as few times as possible. You shouldn't have a bunch of malloc, then free, malloc, then free. And back to like Mr. Awesome's point, the more I don't necessarily think that this is completely fragile. It's as fragile as normal malloc and free is, and how fragile malloc and free is comes down to how many times do you need to actually free memory. And you need to free memory as many times as you did malloc. And so the more malloc you have, the more times you need to go free. And so you should minimize that. And so if we go back to the talk that I referred to earlier from Nick Barker, that one actually goes over how you use like an arena allocator and stuff like that. And I can definitely recommend you knowing about what an arena allocator is, because ultimately that's the sort of trick you would use to minimize allocations. But I don't think it's not fast. It's just as fast as memory management normally is, which is not great. If that makes sense.
Yeah.
Yeah, so we can, the main source of truth is always this header file here, because that's also where, you know, this interface lives, and also the Unity get interface, which is the interface you use to get all the other interfaces. Here's an example of a path where you find it. Yeah, I'm pretty sure we're not. I would be very surprised if that was the case. Okay, another thing, we can actually debug it, debug our C++ code. So here I'm gonna give an example. I can put a breakpoint in, let's say, my additional registration code here. The way I go and debug is just I attach to Unity, like I normally would. This, by the way, also works with Visual Studio or even Rider. But if you're using Rider, when you go and attach, there's a little drop-down button here, and you should change it to use LLDB.
What does LLDB stand for?
I don't know what it stands for, but I know it's a debugger.
Large language dumb-B.
I think the DB might stand for debugger.
It's a large language debugger. Got it.
Sure. So I do attach with bundled LLDB, and that means I'm now when I do that, I will be debugging native code, so not C# code. On Mac, I also have to allow native debugging. There you go. And now look, it has this little checkbox because it did actually find that function.
By the way, I think it's low level because it comes from LLVM, which is the low level virtual machine.
Yeah, okay. Low level debugger, that makes sense. There's also GDB as an alternative, which is also very popular. In any case, I'm using LLDB here. What matters is just, you know, you've done it right when you get at some point get a check mark before you run the code. And okay, so another important thing is the reason I get a check mark is actually it will check as soon as I attached Unity to my debugger, right? It then went ahead and asked Unity, which symbols do you currently have for me? What do I know about that process currently? So the debugger will actually figure out if it knows that Unity loaded some sort of DLL. And so the only reason that we get this check mark is because Unity already loaded the DLL, because I already pressed run code earlier. Right. In either case, now if I go in here and I press run code, I call invoke, right? And pressing the run code just calls invoke Lua. And so it passes in script, and we can see script is that piece of code that we saw inside of Unity, right? We can see that it successfully opened the libraries. We can see that it registered the print function. And now we can also go up to the print function and see what is the implementation there. Well, it is, let's see, loop over every argument, try to convert that argument into a string, and then log it using the logger that we saw earlier. Yeah. So that's what happens if you were to call print inside of Unity. And that's why print now doesn't print using printf, it prints using Unity's logger.
Neat.
And here's the exciting bit. As soon as it goes and calls this function, that's when we know that it's going to go and call some piece of C# code. And so I can actually do this cursed thing here, where I will show what it actually calls into here. So this is the function that we saw earlier. And so if I put a breakpoint here, and I go and attach to Unity, and here you can also see what I meant. Attach with LLDB is the other option. So go and do that.
Unable to connect.
Yeah, and that's because right now the process from Unity is like normally it will ask Unity, hey, is it okay if I connect? And right now it can't really do that because we are still in the native code, right? So it hasn't had time to tick yet. So as soon as I go and do like F5 and continue the code execution, Unity will then resume running the code, ideally. Now I can actually attach it, and we can try this again. Why are you not letting me?
I've had this happen to me before where for some reason it just doesn't want to connect sometimes.
Please load this time. I might have to do this again.
Is there a plugin that is required? It says restart the editor for something about a plugin, but I don't know if that's it.
I mean, I should just be able to normally debug, right? Why is this not? Oh. Anyways, that's the case with live demos. But you can probably guess what I wanted to do here. I just attach the way I normally do with C#, and I would see that as soon as it calls
because
from
it
C-line,
calls the Lua code and then calls in that, and then you would hit that breakpoint.
Yeah, this would call this function passing in Lua state, right? And that's also then where I've registered my something function that calls something really cool, and my make cube function that creates a cube, which is these two functions here.
Right. Yeah.
So the reason that these two functions work is because they've been registered using this mechanism.
I suppose the one thing that you couldn't do is have a breakpoint in the C code and then step through and then get back to your C# code. Like that wouldn't work, right? Because it's kind of
Say that again.
Like you have the breakpoint in your C code and then you like step through line by line. Like it would never bring you back to the C# code, right?
Yeah. Ideally, you don't have code going back and forth between C++ and C code.
Yeah. Yeah.
Lua is kind of the exception where there's actually a useful case for doing this, because you would want your Lua functions, which are technically being invoked through C, to invoke a C# function. Because you would want it to like create an object with Unity or whatever else, right?
Right. Right.
And no, all of the information is just already stored in the DLL because it's a debug DLL. That's at least how it works on Mac. Normally, you would also have to have the PDB side by side with the DLL in order to get the symbols.
Like if you're
in order to get the breakpoints, not the symbols, you would still be able to read.
If you're on Windows, you mean?
Yeah. If you're on Windows, you should, when you build using GCC, you would get the DLL, and if it's a debug build, you would also get the PDB, and the PDB would be the one that actually knows which machine code lines map to which source code lines.
But on Mac OS, that's just baked into the DLL.
It's baked into the bundle. Like if you notice, this thing is called a bundle.
Right. Okay. I'm a Mac and I'm a PC.
Yes. I like my Mac just because it's performant. It's really fast.
Which chip you got in there?
M4 Max.
Wow.
Yeah. It's very fast. It builds Unity faster than any desktop machine. Anyways, there's some best practices. Generally speaking, you should not do any marshalling at all. It's one of the biggest performance concerns. That's also like when Bruce earlier talked about it has its own what's it called, stack, and that's badness. Well, part of that is also if you already had something in heap that lived in the Unity process, then passing by pointers means that it's still going to be in that heap, and so you don't allocate it in that DLL. You allocate it to the process that we already had defined. So if you, for instance, were to use a native array, which is known in this channel, if you do a native array call, you can actually just use get unsafe pointer and then pass that into the C and cdecl functions, and then use that memory, and that's fine. Then you're using Unity memory, you're not using the plugin's memory. And generally, if you just have like primitive data, like a bool or a float or a struct that contains a bool or a float, stuff like that, that's called plain old data, or POD for short. So yeah, you should use that as a data protocol, and then you should just always pass by pointer. You shouldn't do any marshalling. That simplifies a lot of things. Yes, and then ironically, you should minimize the calls between C and C#. I'm saying ironically because in the most ideal scenario, you're not, calling from C# into C++ in the first place. They should work independently. And so, like a case where you could do a thing where it works independently is, like as we saw earlier, is it this code? No, it's this code. Like Unity, when you create a DLL, Unity plugin load and Unity plugin unload will be called by Unity. And so there's no need to go through C# in the first place, because this you can guarantee that this code is going to be called. And so if you can create a DLL that only needs load and unload, it's fine. Or very minimal amount of C# calls into C, it's fine. Yeah. Generally, you should just try to avoid calls between them, or at least when you do have calls between them, you should batch them. So does that mean if we pass a pointer into the native code, modify the data, and then receive it back, we clean it up on the C# side? I mean, sure. Where you do that doesn't really ultimately matter, as long as you try to do it in a batched way. So you don't have a bunch of, like, say you had a bunch of things that you're passing into C#. You don't do a for each in C# that calls a bunch of individual C++ function calls in order to set up that data per object. Instead, you would, like, one of the things that I did recently was I had a popular physics engine called Rapier, which is written in Rust, that I wanted to implement in, that I wanted to work with Unity. The way I made that work is I would pass all of the Unity objects into Rapier, into Rust code, and then I would do all of the processing in the Rust code, and then I would, pass it back. Yes, I think that's a really good analogy. You should think, also because it's similar to a GPU. Whenever you copy it from one place to the other, it's expensive to do that operation. So you should, think of it as two separate buildings that you might be able to talk a little between. Now, okay, I have a bunch of different examples of what you can use this for. Here, this is the talk I just gave. If you want to have the source code to see how you can implement Lua inside of Unity. I also made Odin work. So here I have a spinning ECS cube where all of the code is run with Odin code, and it spins the cube, and it even calls and logs things in Unity. I have an example of tree sitter working. So tree sitter is a popular highlighting library, and also happens to be what I re-implemented into working with Lua for displaying this. It's also the reason why if I press a thing here, I can see highlighted code over in my like preview of the code. I made Rapier work. So there are some examples of what that looks like here. The reason for making Rapier work was that there's this popular thing called space-time database, and space-time database has only really works with Rust, and so you need a if you want things running on the Rust server that is a physics engine, you need it to run with Rust in the first place. And so Rapier is already written in Rust, and so I could make that run on the server. And then I could, because it is a stable physics engine, if I simulated something on the client and I simulated it on the server, I can expect them to match as long as they have the same input. And so therefore I want to use that physics engine inside of Unity instead of the built-in physics engine with Unity. And so I would need a native plugin for that. And so, yeah, that's why I implemented that. And also a guy called Oliver helped out a bit because he wanted to use it. And then obviously DRM GUI is also very popular. So I also made an implementation of that. I don't think there's any picture example, but this actually does work. I even made a thing that can turn all the header files from DRM GUI and turn them into C# code. So you don't have to type it out manually.
So you could like have a bunch of like DRM GUI, like use it for maybe some like debug windows or something inside of Unity.
Yes, correct.
Yeah, that's awesome.
And that's what I did here. Yeah, and that's the link to the GUI. Obviously, now it's also recorded, so you can just, I don't know, copy those links.
I also put the working with native libraries one in the chat there.
Yes.
And then they're all just on your GitHub if you want to poke around.
Yep.
All right. Is that the talk?
That's the entire talk.
All right. I was starring a couple things as we're going along here. So yeah, I guess overall, this kind of sentiment for Mr. Awesome here. This is niche, useful, but not something that the majority of game devs need to know.
Yes,
I think that's pretty fair. It seems like a lot of the things that you're kind of doing, it's like, cool little experiments, but also like, you could build something with it. I think also ITR mentions you could use Bevy as a backend for Unity.
Ironically, you could.
and that's actually not a bad idea because, I mean, I haven't checked recently, but does Bevy like still not even have like an actual like editor to like set up a scene with?
I think there's tools to have a version of an editor, but not a proper one.
Okay, so we can have another one now with you basically using Unity to make Bevy games. But yeah, I mean, to me, like honestly, like as you're going along, like one of the things that it seems like it could be most useful for is like making tools, right? Because like the development platforms that you're going to be shipping on, so that you're not really going to have any issues with like DLL compatibility or whatever. And if something breaks, it's like whatever. Hopefully your stuff is backed up in source control. So I like that's one of the things that I would see it for. Where it was like you come across some cool library online, or we're just kind of talking about using DRIM GUI as like debug windows. Like I think all that stuff would be like cool for just like making better tools inside the Unity editor.
Yes. I mean, I think that's a big part. It's just like, hey, this I don't know, very unique, weird file format. I want a parser for it. I don't want to write the parser for this unique format. True. I want a text highlighter to highlight my code in the editor. How do I make that very quickly? Well, I just have a C library that already does it, and then because someone already wrote it because it's C and everyone writes to C for some reason, or at least expose it in a way that I can expose it to C. And then, it's just a simple matter of, for like the text highlighting, for instance, I just need to pass in a string and I have the library return me a HTML string. And then because it's an HTML string, I can have Unity render that using UI toolkit or whatever else. Actually, just the normal canvas works because there's rich text support, which will allow that. So like it's just a quick way to write a thing that already exists and without having to write it from scratch.
Yeah.
And also, I think another part of why I think it's useful to know about it. I think it's another part of this. I think it's useful to know
that's an option for you. Yeah.
It's useful to know that it's an option for you, but it's also useful to know these tricks because this is actually what Unity heavily relies on internally. All of the principles that I talked about are what Unity has to use as an engine, right? Like whenever you do a debug.log call, you can't see half of that call because it actually invokes into the engine. What does the engine then do? Well, it does things with that. The trick also applies. Like whenever you, use the scene manager, you should actually minimize the amount of calls you do to the scene manager because the scene manager also is a call into C+ code.
So you mean I shouldn't be calling load scene in my update loop?
Well, that's you. But that's given. But like debug.log is also expensive.
Yeah.
Like every single call you do that calls into the engine is more expensive than a call that would just have lived in C# in the first place. And that is going to be even more the case with CoreCLR because CoreCLR tries to heavily inline things in C# as long as it can know the entire context, but it can't as soon as it has to just call the function pointer into C code.
Yeah, that makes a lot of sense. Just kind of gives you more ideas about like how it works. It's kind of like one of those things where like you'll see maybe like I know like Casey Muratori has done this, just kind of like stepping through like the actual code that gets executed when you call like a simple Python function or something.
Yeah.
Like you just kind of like have a little bit more insight into like, oh, okay, like this is actually like doing a lot. But yeah,
Yes. I mean, it always reminds me of the very famous John Carmack article. Oops,
Inception.
very much Inception. There's a John Carmack article that talks about function within functions. You should walk a step in your code, something like that. I'll try to find the quote.
Here's another example of used it to capture audio in C++ and visualize it in VFX graph. That sounds awesome. Because I feel like you could find some good C++ libraries that would do that kind of thing. And then it's I feel like it's just also like not as limiting because like I was talking about at the beginning, like you maybe run into some issues, some limitations in C#, and then when you want to find a solution for that, when you're like looking around on the internet, you don't just type in like, how do I do this in Unity? You can just kind of like find a library that does this, and then it kind of empowers you to just be able to do that with, something that someone has already created, regardless of if it was initially intended to be used for a Unity project.
Exactly. Here's a quote, by the way. An exercise that I try to do every once in a while is to step a frame in the game, starting at some major point like common frame, game frame, render or end frame, and step into every function and try to walk the complete code coverage. This usually gets rather depressing long before you get to the end of the frame. Awareness of all the code that actually is executing is important, and it's too easy to have a very large box of code that you just always skip over while debugging, even though you have performance and stability implications.
Yeah. I mean, I think even just doing that exercise with pure gameplay code is helpful, just to kind of like really understand like how the computer is executing your code, making sure that it like does the thing that you intended it to do. But like actually going into like, what the engine is doing and everything gives you a lot more insight into what's happening.
Yep.
So I know Bonte in his game, they have like a lot of modding support, and they're using Lua. They said we ended up code generating our entire Lua interop to C# because there ended up being a lot of caveats. I think like some of the ones you're mentioning earlier on.
Yeah. Yeah, exactly. And it's not impossible to write code like this, and some developers need to do it. Like one of the if you look in the folder for all the things you can interact with Unity from a plugin directly, there's stuff for pretty much every graphics library, because you might want to do something specific to that graphics library or really tune something. And a lot of AAA developers do that. Or maybe they are working on a game for a platform that doesn't even exist yet, right? But I mean, it's still, for instance, with Lua or a single header library, it might still be easier to just convert it if you can like read through it and understand. Or like if it's a C library, chances are it's very easy to convert. You can maybe even write I've in the past I've written file converters that just like read the raw syntax and turn it into C# equivalent, because there is pretty much a language equivalent from C to C++, from C# to C#, except for defines. Macros are a little special, but
there have been some times recently where I've been wishing there was like a good way to do macros in C#. I know there is like, you do a bunch of code generation stuff all the time, but I'm not as familiar with it, so it's still kind of annoying for me to set it up and everything.
Yeah.
So it's just like, Dude, and I've been like seeing like some of the things that Jonathan Blow has in his language. I'm like, oh my gosh, I need this.
Yeah.
And then Bunte did have another comment regarding allocators. So I think just it looks like most of the allocators are kind of built on top of like Unity's regular, like kind of overall allocator. Is that right?
Yep. Yep.
Sweet.
And by the way, another note about the allocation is that one thing that's nice is a lot of the newer C alternative languages like SIG and Odin, their memory allocators, you can change them, and so you can just implement the Unity allocator as the default allocator for those languages. And I think in the Odin example, I did that.
Nice.
So you can just look at that example if you wanna so that every time you allocate a thing in that plugin, you actually allocate it in Unity. You don't allocate it in Odin. That's separate. Yeah.
Sweet. All right. Anything else before we wrap this up here?
I don't think so.
All right.
Also, actually, just a quick answer to this one. I'm using something called sli.dev. So sli.dev. It's like a markdown tool where you just write your entire thing in markdown, and then it, does nice little code animations, and it's very nice cool. Because whenever you write a presentation for programming, it's very annoying to actually update some piece of code if you wrote it wrong.
Yeah.
If you I don't know, it was a wrong call, and now I need to go in and copy the syntax highlighting again, or maybe I used a tool that generated it into an image. I will regenerate the image. It's very annoying.
Yeah. No,
this lets me animate it even. So
yeah, and I've been I've been liking Markdown quite a bit. I mean, it's so simple. Like that's what my whole the .survivors documentation website is all Markdown, and you just type it in and it looks good on the web.
Yeah.
But yeah, no, I mean, that was cool. Even as you're going along, you're like highlighting the little code bits as you're going on. It's a free program, I'm guessing?
Yep. Yep.
Cool.
I can also quickly just...
Well, I'll beat you to it. Were you getting the link? I just put it in the chat.
Yeah, it's more of I can actually show you how the Markdown looks for the presentation.
Oh, okay, cool.
Let me just... There's also a nice little VS Code plugin for it. So let's say I go to the first, I don't know, what's a good slide? Let me just start the server up again.
Yeah, I saw you're running it on localhost.
Yeah.
Did you see Primogen tweeted out like a QR code today? And when you scan it, it goes to like localhost.
I didn't even see that. No, that's funny. For instance, this thing I'm doing here, where each line is a new thing.
Yeah.
You can see the way I implemented that is just, it's slide 4, which has a fade out transition. So this is the title. I use v-clicks, which is what actually says, hey, every element in this is like a separate slide, effectively. And then v-clicks end. See that? So that's how it does that.
The one thing that I would like, is there like a presenter view? Like you can have like on another monitor, like it shows like the next slide that's coming up and has like some notes and things.
Yes, there is.
All right.
So
well, I'm in for it.
I can show you. It looks like this.
Holy tabs.
There's notes here. You can also see here that it's like, because some slides are multiple slides, it will like.
Awesome.
Yeah.
That's exactly what I'm looking for.
And like writing the animated code that I did was just a simple case of saying, let's see. So here, so it starts by showing the entire thing, because it says show, where is it? Let me actually find a simple example. Yeah, here's a simple example of where I'm changing the line. And so I just say, hey, this is my magic markdown. I'm gonna write some C# code. And then please highlight first line 1, then line 2, then line 3, then line 4, then line 0.
Oh.
So 1, 2, 3, 4.
Yeah, that's cool. So it's like you're basically like putting in like metadata almost to like tell the
Yeah, exactly.
you gotta do it. I like that.
Yeah, it's very nice. I like it.
So yeah, sadly no GDC for Danny nor I this year.
Yeah.
Seemed a little different this year. I know they like kind of did some different branding. It's called like the GDC Festival of Gaming now. And I know Unity didn't have much of a presence at the actual convention. You know, they did most of their like live streams kind of outside of the actual GDC stuff, because
Yeah.
Unity, like in the past, they've probably spent so many millions of dollars on like being, because like they're like a top level sponsor of GDC, and they had like talks running like nonstop throughout the week. Like that probably cost a shit ton of money. So
yeah.
But yeah, so I know a few people were there, like Code Monkey and Sammy M were there. I think Jason Wyman was there too. So I haven't got a chance to talk to them to see how it was. But ITR says my boss was interviewed by Unity during GDC, so a video of that might appear in a few months. Awesome. How what did I know? Like, do you have a name of the studio? I don't remember what your studio's name is called. Just want to be on the lookout, or even just what your boss's name is, to see if that pops up. Then did you see this DLSS 5 junk?
Yeah, no, that's very much slop. Holy shit, it looks bad. It's so awful.
Look, I mean, I think DLSS is like an interesting technology for sure, but
yeah, I like 4.
So
what the fuck happened to 5?
What I've seen of 5, it's not looking good.
It went from image upscaling to just slop.
Yeah, true. I feel like a lot of people have been kind of focusing on like it just kind of looks like, like an Instagram filter or something. But there was also like, I would see like people moving around, and there was like some like ghosting kind of happening. Were you seeing that?
But that's actually what I'm annoyed at.
That's what, like, yeah, that was the thing that stood out to me most, because I'm like, I see like the like phases or whatever. I'm like, all right, they both like kind of like pretty good or whatever. But that was like really bugging me. I'm like, all right, is that like hurting my head right now? Like,
it looks awful.
Yeah. So, yeah, no DLSS 5. And I mean, the games that I am making right now and want to make wouldn't need any kind of like crazy upscaling anyways. So, I'm not too concerned. The game I'm working on is a little more stylized right now. And by the way, ITR Megapop making Life Below shared on Discord. Awesome. Thank you much. DLSS 5 could be applied to legacy games. Well, I mean, sure, like, yeah, it's upscaling and stuff, but then it also is, it's just kind of like making it into its own thing, right? I
Yeah.
think what a lot of people have been saying, and rightfully so, is the artists kind of have like an intent of like how they wanted to specifically create the look of some characters, and this just almost like paints right over it, says, no, we can do it better, right?
Yeah, exactly. Yeah.
Minesweeper DLSS 5.
Now with actual
It's just
bugs.
Minecraft.
Yeah.
All right. Well, with that, I guess we'll wrap it up. I mean, it's gotta be like, is it like 1:30 in the morning for you right now?
Yeah, 20 past 1.
So yeah, it's just the middle of the day for you. So we'll go ahead and wrap this up here. What is this? Even the previous upscaling filters had the problem of beautifying humans and making them look more generic. I mean, yeah, I guess that kind of makes sense, because at the end of the day, it is like an AI thing where it's like,
loses soul and just generifies everything.
Yeah.
Into the most common denominator, and that's
I saw a funny thing online that was like, games in the future are just going to be like this, and it's just like literally like 3 blobs, like person, building, car.
Yeah.
So
let's wrap up.
Okay.
Before we keep
this going forever. All right. But yeah, thanks everyone for joining us here for the Hot Path Show. Thank you, Danny, for coming by and giving your talk again about using external libraries in Unity. Sparked some good discussions with the chat and everything. So really do appreciate that. And yeah, enjoy your weekend, and have fun, do whatever you're gonna do. Any parting words for the people, Danny?
Stay safe. I don't know.
Stay safe.
See you.
All right, everybody. We'll see you in another stream at some point, sometime, hopefully soon. Later.
Yeah.